Let's talk about the earthquake that happened yesterday in Japan. A large earthquake, magnitude 7.0, struck in an area that has seen major devastation in the past. Now, we're approaching 200 aftershocks in the higher magnitudes, which is alarming. Many people might remember the 2011 Tohoku megathrust earthquake and tsunami, or even historical quakes that reached magnitude 9 or more. So the big question is, are these aftershocks normal, or could they signal something bigger coming? Here's the update. If you look at live earthquake maps from agencies like the Japan Meteorological Agency or USGS, you'll see dozens of new quakes clustered in the same region. It might seem like the ground is becoming more unstable, but what you're seeing actually follows well-known seismic rules. This doesn't mean there's no risk, but it also doesn't necessarily indicate an escalating disaster. Yesterday's quake struck along a major fault system in Japan, part of the subduction zones where the Pacific plate is sliding beneath the North American and Philippine plates. This region is extremely tectonically active, with frequent earthquakes and volcanoes, making it one of the most studied areas in the world. When a magnitude 7 earthquake happens in Japan, a large section of the fault suddenly releases stress that is built up over decades or centuries. The energy radiates outward, redistributing stress across nearby faults. Some parts of the fault unload violently, while other sections are pushed closer to failure without breaking immediately. This redistribution triggers the aftershocks we're seeing now. Within minutes of the main shock, aftershocks began. By this morning, analysts have counted nearly 100 above magnitude 3, with countless smaller ones below magnitude 3. While the numbers sound dramatic, they are actually normal for a magnitude 7 event in Japan. The concern is always there, but science shows that this is a standard sequence rather than an escalation toward disaster. Fortunately, no major landslides or tsunamis have been reported so far. Landslides are a risk in Japan, especially in coastal fjords or steep mountainous regions, because earthquakes can destabilize slopes and trigger localized tsunamis. Historical examples, like the 2011 Tohoku earthquake, show that a combination of strong shaking and unstable terrain can create devastating waves. The aftershocks lighting up the region are not separate disasters, they are the Earth adjusting to the sudden stress change caused by the main quake. This follows Omori's law, which says that aftershocks are most frequent immediately after the main shock and gradually decline over time. Right after the main shock, activity is intense and then it decreases steadily. Why does it look especially dramatic in Japan? Because the country sits on multiple complex fault systems and subduction zones. When a magnitude 7 earthquake occurs, the stress redistribution affects many nearby faults, causing multiple small slips that appear as aftershocks on the map. History provides perspective. In 2011, the magnitude 9.1 Tohoku earthquake generated thousands of aftershocks, some exceeding magnitude 7. Yet, even after such an immense event, the region eventually stabilized without triggering a larger, unexpected quake in the short term. Similarly, previous magnitude 7 events in Japan, such as the 2003 Tokachi earthquake, produced many aftershocks but did not escalate into a larger rupture. Modern seismic networks in Japan can detect very small earthquakes that would have gone unnoticed decades ago. That's why today, aftershocks seem more numerous and intense than before. Although many aftershocks are above magnitude 3, this is entirely expected in the context of Japan's seismic activity. So, is this a precursor to something bigger? Statistically, the answer is no. For a magnitude 7 earthquake, the probability of a larger quake following in the short term on the same fault system is typically around 2 to 5%. That means in roughly 95% of cases, the main shock is the largest event in the sequence. Aftershocks relieve stress, they don't recharge it. Magnitude 5 to 6 aftershocks may still occur, and that is normal. The period of greatest risk is usually the first 24 to 72 hours after the main shock, when the strongest aftershocks occur. During this time, damaged structures are most vulnerable and secondary hazards like landslides are more likely. As days pass and the aftershock rate declines, the probability of a larger follow-up quake also drops. A common misconception is that aftershocks build up to a major earthquake. In reality, aftershocks are the fault's way of releasing leftover stress from the main rupture. True aftershocks should be distinguished from foreshocks or separate seismic events, but current data shows that what we're seeing in Japan is a classic aftershock sequence. For those in affected areas, it's important to remain alert. Stay away from unstable slopes, rivers, and coastal areas during the first days after the quake. Aftershocks can still be strong enough to damage buildings, topple trees, or trigger landslides in mountainous regions. In summary, yesterday's magnitude 7 earthquake in Japan produced a high number of aftershocks, which is normal given the tectonic environment. These aftershocks represent the Earth adjusting to stress changes, not a signal of escalating danger. Historical events in Japan show that such sequences rarely lead to larger earthquakes immediately afterward. Aftershocks are part of the Earth's natural process of stress release. Japan's seismic monitoring systems and emergency preparedness measures are among the best in the world, which is why awareness, not fear, should guide our response.